In 3.3, we get to learn a different way of taking a derivative, and this is going to happen throughout the semester. We're going to learn all kinds of new rules for differentiation. So where in 3.1 and 3.2, we found the derivative by taking the limit as h approached 0 of the difference quotient, it's going to be pretty simple today, because the rules are just, pretty straightforward. So if you look at the first one, it says when you take when f has a constant value, so when your original function is just a constant, the derivative, so ddx, or you could say ddx of c is 0. F prime is 0. F prime of x is 0. Y prime is 0. There's so much notation, and that can actually be the confusing part here. So I could say that just f prime of x equals 0, because that's just a constant for a. Now, for example 1b, that's not just a constant. We have a variable there. So this is actually the first time that we get to use the power rule. And it says when you're taking the derivative, if you have a ddx and there's something behind it, that means take the derivative of what's behind it. That's just one way of asking to find what the derivative is. Anyway, when you have something to a power, what you'll do, you'll bring that power, that n, out front. You'll keep your variable, but you'll raise it to the power of whatever your n was minus 1. Okay, so let's try it out. And I'm sorry, I wrote that in black down there. I usually like to write my work in blue. So n in this case is 2/3. So ddx of x to the 2/3. I'm just trying to, by writing that ddx, I'm trying to just give you a different notation and get you used to seeing that. But 2/3 is your n, so you will bring that out front and then multiply it by x, and x is raised to the power of 2/3 minus 1. For these, just realize that 1 is equal to 3/3 in this case. So your final answer is 2/3 x to the negative 1/3 power. Right here on C, I get y prime. Again, I'm just using some different notations. This is all, and it's not specific of what notation I need to use right here, because it didn't say f of x equals x to the square root of 2, or it didn't say y equals x to the square root of 2. It just said, x to the square root of 2. So I'm just playing with that notation. Your n, your power is the square root of 2, so that comes out front. And you multiply that by x, and it's raised to the power of what your n was, minus 1. And to my knowledge, that doesn't simplify. So now let's look at what we have left. On this one, your n is negative 4/3. You're going to bring that out front and raise x to the power of negative 4/3 minus 1. So in this case, think of 1 as 3/3. Be careful with that power, because that power is a negative. I have a lot of people mess up there a lot of times. So negative 4/3 minus 3/3 would be negative 7/3. Now I'm going to let you leave it at negative 7/3, but you could move that x to the bottom and call it negative 4 divided by 3x to the negative 7/3 and put the x to the negative 7/3 in the denominator, and it would be positive if it were in the denominator, but you can leave it just like this. Okay, so on E, I'm going to have to rewrite that one because right now it's not just, it doesn't fit my rule. It doesn't fit my rule of x to a power because x is trapped inside of another function. Right now it's trapped inside of a square root function. So I'm going to rewrite my original function, my f of x, as x squared plus, and that pi is up here as a power. And instead of writing the square root, I'm going to write the 1/2 power. And from the power rules that we went over in 1.5, we know when we have a power to a power that we multiply those together. So I essentially say 2 plus pi times 1/2, which comes out to be x to the power of 2 times 1/2 is 1. Pi over 2 times 1/2, pi times 1/2 is pi over 2. So f prime x, the n is 1 plus pi over 2. X gets raised to the power of your n, so 1 plus pi over 2 minus 1, which simplifies down into 1 plus pi over 2 times x to the pi over 2 power. The ones canceled. And then for f, this one's pretty easy because it's just a constant, so our derivative is 0. We're looking at another rule. And really it's not doing much to the power rule. It's the derivative constant multiple rule. So if u is a differentiable function of x and c is a constant, then d dx of c times u is the constant. You keep your constant and take the derivative of the function. Now that looks super complicated, but all it's saying is 3 in this case is a constant, and you have x squared, the function of x squared behind it. So keep your constant, and then multiply it by the derivative of the function being x squared, which comes out to be, so keep the 3. When I'm taking the derivative of x squared, the n in this case is 2. So you put a 2 out front, you raise x to the power of 2 minus 1, which is the first power, so I come up with a nice answer of 6x. Okay, in this case, our constant is -1, right? So I'm just going to write down -1 and multiply by your n, which is 3, and raise that to the power of 3 minus 1, which comes out to be -3x squared. So this derivative sum and difference rule is just great. It's super simple. What it's saying is that if you're taking the derivative of not just a monomial like x squared or 3x squared, but a polynomial, that all you do is literally take the derivative of each part of that polynomial, and keep the sign that was associated with it. So in this case, addition. In this case, down here, subtraction. So it may make a little bit more sense if I write it down for you down here. D dx is equal to, you got to take the derivative of x cubed, and you got to take the derivative of 4/3 x squared, and you gotta take the derivative of 5x. You gotta take the derivative of 1. And you don't have to write it out longhand like I just did. I'm just trying to show you what that rule is telling us. So our answer, okay, the derivative of x cubed is, your n is 3, so bring it out front. X is raised to the power of n minus 1, so that's 2, right? Okay, 4/3 is a constant. You bring the 2 out front, and x is raised to the power of 2 minus 1, which is 1. 5 is a constant, you keep it, and the derivative of x, the derivative of a variable to the first power is always 1, okay? Because what you do is you bring the power of 1 out front, and then you say x is raised to the power of 1 minus 1. Well, that's the power of 0, and anything to the 0 power is 1. So when you have a variable to the first power, it's always 1. Just be sure if it has a constant in front of it, you keep the constant with it. And then on the end, we have the derivative of 1 is 0. So let's clean that up a bit. And we are good. Now, does the function, or the curve, x to the 4th minus 2x squared plus 2 have any horizontal tangents? Well, what you have to do is you have to find the derivative and set the derivative equal to 0 and solve for x. So, y prime, 4x, 4 minus 1 is 3. I'm going to keep the 2 out front, but then I have to bring a power of 2 in the front, so that's going to be 4, and x to the power of the 2 minus 1 is just 1. And then the derivative of 2 is 0. I'm not going to even write that down. So I've got the derivative, but it didn't say just take the derivative. It asked me a question beyond that. Does it have any horizontal tangents? So I'm going to set 4x cubed minus 4x equal to 0. And let's see. I can pull out a GCF of 4x, and I'd be left with x squared minus 1. And that factors into 4x and x plus 1 and x minus 1. That x squared minus 1 is a difference of squares. So set your factors equal to 0, and you have horizontal tangents at the x value of 0, -1, and +1. Now, this question could go a step further and say, at what point do you have horizontal tangents? Well, in this case, you have horizontal tangents at 3 points. So you would need to go one step further and plug 0 and -1 and +1 into your original y function to find y values for those x values. So going forward, we have two new rules we're looking at. The derivative of a natural exponential function, one of my favorite derivative rules. The derivative of e to the x is e to the x. As simple as that sounds, that's going to drive some of you absolutely crazy, okay? But just keep that in mind, okay? And we're also going to learn a product rule. So we've talked about sums and differences, and those were pretty simple because you just took the derivative of each part and then added it or kept the sign, right? Well, the multiplication, and later on we'll look at division, is not quite that simple. It's not as simple as taking the derivative of one thing and the derivative of another and multiplying them together. Here I have it written two different ways. The derivative of u and the derivative of v. So here's your first function, here's your second function. So copy and paste your first function, take and multiply by the derivative of the second, and copy and paste your second function and multiply by the derivative of the first. It actually looks a little better if we look at it right here, and it's just saying, and I memorize in my mind, this is how I say it. First, I say first derivative of the second, second derivative of the first. First derivative of the second, second derivative of the first. Okay? On example A, 5A, I don't have to use a product rule right here because it's saying -5 times e to the x. Now, if that would have said -5x times e to the x, that would require a product rule. But -5 doesn't have a function with it. It's just a constant. So all we have to do for y prime here is bring down that constant and then take the derivative of the function behind it, and the derivative of e to the x is e to the x. So in that case, that's one of those cases where the derivative is actually equal to the original function. Okay, but now on part B right here, I have 1 over x times x squared plus e to the x. And let me read that one more time. 1 over x times x squared plus e to the x. Did you hear that times when I said times? It's pretty dramatic about it. And that's because that requires a product rule. I am going to rewrite the original function to say x to the -1. Because technically 1 over x is, that's technically a quotient rule, the division, right? Well, I don't know that yet, so I'm going to write it as x to the -1. I'm just going to bring that x to the numerator. So x to the -1 times x squared plus e to the x. So when I'm first learning how to do this, what I like to do is label everything. So let's see, f of x, or in this case, u and v. And let me just go back and say this. You could say dx of f of x times g of x is f of x times g prime plus g of x times f prime. And this is saying the same exact thing. It's saying first derivative of the second, second derivative of the first. And I'm writing it like that because that's the way that I learned it. And when I do my labeling, I usually say f of x and g of x. So let's just do this in a different color. F of x, so the first function is x to the -1. The second function is x squared plus e to the x. Okay, the derivative of the first function is, okay, the power rule. So I bring the -1 out front, and I raise x to the power of -1 minus 1, which is -2. The derivative of the second function, 2x plus the derivative of e to the x is e to the x. Okay, and so now I want to remember that rule, the one that I just wrote down, and y'all, I'll write it down every single time that I use it. Because it just helps me memorize it and helps me hold myself accountable whenever I am plugging things in. So, first function, I literally copy and paste it, and we said that was x to the -1. G prime, or the derivative of the second, we said was 2x plus e to the x. Okay, the second function is x squared plus e to the x. You're literally copying and pasting what the original was. And the derivative of the first is negative 1 x to the negative 2. So from here, I want to make it look a little better and distribute some things out. When I say 2x times x to the negative 1, with your x's, you keep the base and add the exponents. Well, negative 1 plus this power of 1 right here is 0. So that's actually x to the 0 power, which is equal to 1, but we'll go back and write it just the number 2 later, okay? So now x to the negative 1 times e to the x, well, that's, I can't do anything there but just multiply it and say that I did it, okay? So now I'm going to distribute the negative 1x to the negative 2 to the binomial in front of it. And so that would be, okay, so let's see, negative x to the negative 2 times x squared, you add those exponents, you're going to get x to the 0 power again. And then negative e to the x times x to the negative 2. That's a situation like what happened right here, okay? So let's clean it up some more. I think it would look better as e to the x over x. That's our final answer there. And here's a fun one. Okay, so our first function, and I'll do the labeling in red. Your first function is x squared plus 1. The derivative of that function is 2x. Your second function is x cubed plus 3. Your derivative of that function is 3x squared. And remember, first times the derivative of the second plus the second times the derivative of the first. So, and make sure you label things y prime. I will count off for not labeling your derivative. I don't want to have to go looking for it. Your f of x, okay, so x squared plus 1, literally copying and pasting it, times your derivative of the second, so 3x squared, plus g of x, so your original second function is x cubed plus 3, times the derivative of the first function, which is 2x. And so now I'm going to distribute here. X squared times 3x squared is 3x to the 4th. 3x squared, 1 times 3x squared is 3x squared. 2x times x cubed is 2x to the 4th. 2x times 3 is 6x. So let's combine like terms, 5x to the 4th plus 3x squared plus 6x. I will say this. All this labeling up here, oops. I'm not going to make you do that on your test. However, I highly suggest it. I highly suggest you writing the formula every single time. But I'm not going to make you do those two things. Now, the work in blue, I do need to see that. If for some reason you have all of this written down and then miss something down here, if you've labeled things up before you got started, it'll be easier for me to give you partial credit. If I don't see what you were working with to begin with, I can't give you partial credit. So I'm not requiring that you label things out, but I do highly suggest it. And finally, we have the quotient rule, which is a lot like the product rule. But now in the product rule where you were saying first derivative second plus second derivative of first, you kind of do that backwards here. Because you'll notice if you have u divided by v, you're starting with writing the bottom and then the derivative of the top, and then multiplying and then subtracting the top times the derivative of the bottom all over the derivative of the denominator squared. Now, quite frankly, the way I like to write it, now, and the order does matter because of that subtraction sign. The way that I like to write it is if you have, and I'll put it right here, if you have an n of x divided by, and let me just make that lowercase, divided by d of x, and you're taking the derivative of it, then what it will be is, and let me just tell you, I'm being strategic with calling this n and d, because n stands for numerator and d stands for denominator, right? I'm just helping myself out. So what you have is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. For me, I really like looking at it like this. I'm super visual, and I see that, now look, this is just me trying to teach you how to memorize this. I see that these D's are kind of like forming this triangle type thing visually, right? And the N's are on the inside, right? So start with D, end with D, divide by D, okay? And the N's are on the inside. Okay, so let's label this thing out. So the numerator, the numerator is, and look, this is going to be tedious, and you're like, why do I have to label this out? You don't. I'm not going to make you. But I do highly suggest it. I think it will help. D equals t cubed plus 1. So d prime, 3t squared. And just remember, d n prime minus n d prime over d squared. And look, these primes, they're looking a lot like little ones, right? Like to the first power, but that's not what it is. It's really an apostrophe, okay? Anyway, so let's plug this in. So y prime is t cubed plus 1 times the derivative of the numerator, so 2t. And look, I'm not having to do any thinking here. It's labeled. It's clearly labeled for me. Minus, let's see, n is n squared minus 1. The derivative of the denominator is 3t squared, all divided by the denominator squared. So t cubed plus 1 squared. So we can't leave it like that. Let's simplify it out. 2t times t cubed is 2t to the 4th. 2t times 1 is 2t. I'm going to distribute the 3t squared to the binomial in front of it, but at the same time I distribute the 3, I'm also going to distribute a negative 1. So that's going to be negative 3t to the 4th. And then it's a negative and a negative, so a positive 3t squared all over t cubed plus 1 squared. So 2t to the fourth minus 3t to the fourth is negative t to the fourth plus 3t squared plus 2t all over t cubed plus 1 squared. This one tells us the answer. So I guess that's just something that we need to remember for right now. E to the negative x is really 1 over e to the x. But just remember that the derivative of e to the negative x is negative e to the negative x. It brings that negative out front. Okay, now, this one down here. This is great, okay? Because what you have is something times something divided by something. So you have a product rule inside of a quotient rule. Or you have no, you don't have a quotient inside of a product. You have a product inside of a quotient. So what we're going to do is we're going to take let me just write that quotient rule down again. It's the denominator times the derivative of the numerator minus numerator derivative of the denominator all over denominator squared, okay? Well, look, I can label denominator and the derivative of the denominator super simply, but when I take the numerator and the derivative of the numerator, I gotta use a product rule. So let's label some things out. Numerator is x minus 1 times x squared minus 2x. I'm not going to do n prime just yet because that's going to require a product rule, okay? And then the denominator is super simple, right? Denominator is x to the fourth, and the denominator, the derivative of it is 4x cubed. So let's perform a product rule with this numerator. Remember, the product rule is the first times the derivative of the second plus the second times the derivative of the first. So x minus 1 times 2x minus 2 plus the second, so x squared minus 2x times the derivative of the first, which the derivative of x minus 1 is just 1. And look, y'all, this isn't even simplified yet. I have to simplify this product rule. What's going to happen right here is I'm going to have to FOIL x minus 1 times 2x minus 2 into x times 2x is 2x squared. X times negative 2 is negative 2x. Negative 1 times 2x is negative 2x. Negative 1 times negative 2 is positive 2. And then x squared times 1 is x squared, and then 1 times 2x is negative 2x. And that actually simplifies further because there are like terms. There's an x squared and a 2x squared, so that's 3x squared. And there is, 1, 2, 3 negative 2x's, so that's negative 6x. Okay, so I'm plugging, I'm plugging, this is the derivative of the numerator, n prime, and I'm plugging this in. I'm going to plug in the denominator and the derivative of the denominator into the formula up here. So, denominator. Denominator was x to the fourth times the derivative of the numerator. So 3x squared minus 6x minus the numerator. So x minus 1 times x squared minus 2x times the derivative of the denominator. All over the denominator squared. Okay, so from here, there's several ways to go about simplifying this. I do need to perform this multiplication, factor it out after that. From the get-go, I really would like to do some common factors, and really, I wish the 3x squared minus 6x right here, I wish it happened right here, but it kind of does, because what you can do is rewrite this as, golly, I hate to write all this down again. Anyway, you see here where I factored out that 3 from the 3 and the 6, and I'm left with x squared minus 2x. Well, now I can say that x squared minus 2x is a common factor, like a greatest common factor. And let's see, there's an x to the fourth going on, and an x cubed. I can take out an x cubed as well. And I would be left with, okay, so bear with me, and I'm going to put what I'm left with in brackets. So since I'm pulling out an x cubed and an x squared minus 2x, if I'm pulling out an x cubed from x to the fourth, that's right here, I'm left with just an x. So I'm taking 3 x's away from the 4 x's, okay? And then if I take an x squared minus 2x away from this, I'm just left with that 3. Okay, so let's pull the GCF out of the second part right here. First of all, the x minus 1 doesn't appear in the greatest common factor at all, so I'm gonna just write it back down. X squared minus 2x, so these kind of come out as 1, so I'm not going to write a 1 down. X cubed, I'm going to take that out of the 4x cubed, and I'll just be left with the number 4. I'm just going to call this x to the 8th. So what I've done here is basically just do my multiplication and distribution inside the brackets there. And so now I need to combine my like terms. So I've combined my like terms from what was originally inside the brackets, the 3x and the negative 4x became negative x. And what we're wanting to do now is have an answer that is just fully factored. Like you can't factor it or simplify it any further. And I'm wanting to cancel x cubed with 3 of the x's and the x to the 8th down here. But before I do that, I do notice earlier when I took out, let's see, I took out a 3 from the 3x squared minus 6x. Could have also taken out an x, right? They both had an x in common. And if you'll notice, that x is still there. So I can still take this x out. And golly, if I have to write this thing down one more time. If I take that x out, it's going to go with the x cubed and be x to the 4th. And I'll have x minus 2 times, x minus 2 times negative x plus 4 all over x to the 8th. And that's going to clean up. The x to the 4th completely cancels. I'll be left with x minus 2 times negative x plus 4 over x to the 4th. One more thing in this section is higher order derivatives. So if you say f prime, that's saying take the derivative, but you could also take the derivative of the derivative, which is the second derivative. And in some cases, you can take the third derivative and the fourth derivative. And it's really, really simple. I'll show you an example of this on the next page. So here it says find all derivatives. So first, second, third, fourth, fifth, how many ever you can find. So the first derivative, and I'm going to denote that as y prime, or f prime of x, is 3x squared minus 6x. Well, the second derivative, or you could y double prime, f double prime x, is, okay, you can take the derivative of your derivative, which would be 6x minus 6. And I can take a third derivative, triple prime, and even a fourth derivative. As the derivatives get higher and higher, you might see it written as, instead of 4 primes out there, you might see that 4 abbreviated. And the derivative of 6 is 0.